If you watched the last video about how to convert from one measurement system into another, then this problem shouldn't pose much difficulty. The difference here is instead of using exact measurements like a given set of length or weight or something like that, we are going to be converting rates from one rate into another. So in the last video I mentioned how a rate is basically a ratio. For example, when you see something like 3 meters per second, that's really a ratio. Either 3 meters per 1 second, that would be what's called a rate, or technically that would be the same thing as 1 second for every 3 meters walked, depending on what you want to think about. So the question is, how many feet, so really our answer wants to be in feet, are we going to walk in 1 hour? So we're also given something about hours. So when it comes to dealing with a problem like this, using a rate to get us an answer, we're going to really rely on that structure that we previously talked about. So we're going to start with what we're given, 3 meters in every 1 second. Okay? And the way that we're going to do this is we're going to think first about converting our meters into feet. And I don't know if you know this, but the only accurate, reliable conversion between these two systems of measurement, imperial, which is feet that we use here in the States, and international, which is going to be the SI or metric system that is used in science and in most other international countries, the only reliable conversion factor is 2.54 centimeters is the same as 1 inch. So this is going to pose a little difficulty because what we're going to need to do is go first from meters into centimeters, and then once we're in centimeters we can convert over into inches, and then from inches we can convert into feet. There are a few other conversion factors that exist, but this is really the only reliable one. So if we have meters here, we're going to go ahead and put meters down below, and we'll put the type unit that we're going to convert into, which is in this case centimeters. For every 1 meter, you have 100 centimeters, and I'm going to go ahead and just make sure that I divide my units so that I'm staying on track. So at this point in time, if I stopped, my units would be centimeters per second. Let's go ahead and go from centimeters into inches. So we'll put centimeters down here, so these will divide, and inches in the numerator. For every 1 inch, there are 2.54 centimeters, and I'll make sure that I divide my units to 1. So now I'd be in inches per second if I stopped. We'll now go ahead and go into feet. So inches will go down in the denominator and feet in the numerator, so that inches are going to cancel. So 1 foot is 12 inches. So if I stop right here, I have 1 foot for every 1 second, or excuse me, feet for every second. Okay, the number is going to depend on all the math that's going on here calculationally. So we're good there. Let's go ahead and look at the bottom, and let's now convert from seconds into, or using, what we were told, which was 1 hour. So what we'd like to do here is basically multiply by some sort of a conversion. If seconds is in the numerator, in the denominator, we want it to be in the numerator here. And there's two things. We need to ask first, can we go from seconds into hours? And if your answer to that question is yes, then what you would be doing is you would be doing the calculation of 3,600 seconds that go by in 1 hour. You would cancel those units, so the seconds would be gone, and then you would now have a measurement that's in feet per 1 hour. And that's going to be handy because we're talking about our measurement being an hour. So you could also technically multiply by 1 hour, and that's going to get rid of those. But let's say you did not know this conversion factor existed. Let's think that all you knew was how to go from seconds into minutes, because that's what most people know how to do. So instead, we'd go with our seconds that were down here, and we'd continue putting the seconds in the numerator, but now we'd go to minutes. So 60 seconds in every 1 minute. And now we'd be in feet per minute. We'd then go ahead and go from minutes into hours. So minutes will go in the numerator, and hours will go in the denominator. There are 60 minutes in 1 hour. So combining these two together is where that 3,600 number came from that was the seconds to hours conversion. And one thing I should always do is make sure that I'm dividing out my units to ones so that I'm making sure that I have what I want. So right now we have feet, which is the question that we were supposed to answer, per hour. Since I only said 1 hour, not 2 hours, we could technically stop and use the rate because this is per 1 hour. But I might just go one step further just to make sure that hours are going to cancel. So 1 hour is a number that I know, and those go away. So now my answer will be in feet. So in order to do this, we have to do 3 times 100 times 60 times 60, or you might have 3,600, and divide that by whatever this is. And we want to do that in a calculator all in one step. So this is what that would look like. That should give us a final answer, 433, and then there's a decimal that's there, so we'll go ahead and just say 0.1. Again, as mentioned in science classes, you'll learn about how to cut this number down, but this is the number of feet that you would tackle. So this problem looks really intense and really crazy and hairy, and it kind of is, but you can see in this problem why the structure of staggering units is so incredibly important to keeping you on track, because it's really hard in your head to figure out where the numbers should go and what you should multiply by and what you should divide. So we should be able to put our conversions to work to answer a question like this. This one will be a little simpler, I think, than the last. So we have a pool that is draining, and it's draining at a rate of 12 gallons for every minute. So the question might be, how many liters is that per hour? So in order to do that, we'll need to employ this conversion factor, which again can either be rewritten as 3.785 gallons over 1 liter, or 1 liter divided by 3.785 gallons, since they're the same actual amount. That ratio is really 1. So let's go ahead and start with our initial quantity, 12 gallons for every 1 minute. And we know that we want our answer to be in liters per hour, so I'll know that I'm done when I have liters in the numerator and hours in the denominator. So let's go ahead and work with the top first, our gallons. We should be able to convert directly from gallons into liters. So if we do that, we'll put gallons in the denominator so that these will divide to 1. So we know that it's 3.785 gallons, and we're converting into liters, so that will go in the numerator. So we'll get a 1 up there. So gallons will divide, and right now we'll be stopping with liters in the numerator, which is what we want. So that's good. Let's go ahead and then go from minutes into hours. So if minutes is in the denominator, it's got to be in the numerator so that we can create division to 1. And we'll go from minutes into hours. So we can divide out our minutes, and we know that there are 60 minutes in every 1 hour. So our only calculation is to do 12 by 60 and divide that by 3.785. When we do that, we should come up with a final answer of 190.2 roughly. So again, we'd put approximately equals. And then our rate is liters, and you can either write it as liters per hour, or you could write it as liters over 1 hour. So you could also say liters per hour, something like this, that would all be acceptable answers.